What if the biggest obstacle to deploying intelligent reasoning systems in enterprises wasn't the complexity of the questions, but the astronomical cost of building the knowledge needed to answer them? This paper introduces a practical framework that makes graph-based retrieval-augmented generation affordable and scalable for real-world enterprise applications. Building on that foundation, let's examine the core barriers that have prevented widespread GraphRAG adoption. The researchers identified that GraphRAG systems face two critical bottlenecks. First, using language models to construct knowledge graphs incurs massive computational expenses that make enterprise deployment impractical. Second, existing graph retrieval strategies introduce latencies that undermine the system's utility for time-sensitive applications. To overcome these obstacles, the authors propose a fundamentally different approach to both construction and retrieval. Instead of relying on language models, the framework uses dependency parsing techniques from established NLP libraries to extract entities and relations directly from text structure. This approach remarkably retains 94% of the performance achieved by large language model-generated graphs, while slashing computational expenses. For retrieval, the system introduces a lightweight strategy that identifies relevant query nodes in the knowledge graph and performs targeted one-hop traversal. By incorporating dense vector re-ranking, the approach extracts precisely the subgraphs needed for answering complex queries without exhaustive graph searches. The retrieval architecture illustrates how the system seamlessly integrates hybrid node identification with traversal operations. This design allows the framework to balance semantic relevance with computational efficiency, ensuring that only the most pertinent knowledge structures are retrieved for downstream reasoning tasks. Now let's examine how this framework performed when validated on real enterprise datasets. Testing on two SAP enterprise datasets revealed substantial improvements across multiple dimensions. The system achieved up to 15% better context precision compared to dense vector retrieval baselines, while the dependency-based graphs delivered performance nearly indistinguishable from their expensive large language model-generated equivalents. While the results are compelling, the researchers acknowledge important limitations. The evaluation centered on SAP datasets, so generalizability to other domains remains to be validated on broader benchmarks like Hotpot QA. Additionally, dependency parsing inherently captures explicit syntactic relationships, potentially missing implicit semantic connections that human readers infer. This work demonstrates that enterprise-scale GraphRAG is not just theoretically promising but practically achievable today. By decoupling expensive language models from graph construction and introducing efficient hybrid retrieval, the researchers have opened a pathway for explainable, cost-effective reasoning systems in complex real-world applications. Visit emergentmind.com to explore more cutting-edge research transforming AI deployment.